Well, students, we have already covered Unit 1 and Unit 2. Can anyone tell me the definition of machine learning? Please be quick in answering. At least type that definition in the chat window. Well, now I'm not going to explain it again. You have to respond, students. Now we are in the concept of classification. Let us learn what a classification is. In Unit 1, we covered basic math. Unit 2 is about regression. Unit 3 is about classification. Instead of writing detailed rules for a computer to follow, you give it data and let it discover patterns on its own. Yes, absolutely. So we are here. Classification concept. It is a supervised ML technique used to predict labels or categories from input data. Classification is a supervised ML technique. That is the first point. Second point is it is used to predict labels. Labels are also called as categories or targets or class from the input data, and it uses labeled data. It assigns each data point to a predefined class based on learned patterns. Just now what Janvi said is that it discovers the pattern on its own from the data. Whatever pattern it has learned during the process of training, using that it assigns each data point. Each row is called as a data point. Each column is called as a feature or variable, and we have a column which is a class, which is also called as a label or a target or a category that represents the class to which the data point belongs. Um, Moving on to this different concepts in classification, it predicts the categories. First main important concept of classification is that it predicts the category and it determines the class of new data points. Second one is it uses labeled data. So it is trained on data sets where the correct class is known. You have a data set in which you have input as well as output. Input are the features, output is the class. And common examples of classification includes spam versus non-spam emails. This is classification, classifying email into spam or non-spam. Classifying the patients based on their reports into diseased or healthy classes. A classification model might be trained on data set of images labeled as either dogs or cats. This is another example where we are providing our model the data set of images that contain dogs and cats with their labels. It can be used to predict the class of new and unseen images based on the features such as color, texture, shape that it has learned. In the training data, you observe these are the pictures of um, here it is shown like one image. However, in the real data set, you have multiple images of different types of dogs, and you have different cat images. You train the model using this training data, and once the model finishes its training, you provide a new image to the model. It classifies that image into either cat or dog category, and because here the image belongs to the cat, it is and if it is giving its class also as cat, it means that it is correctly classifying the image. Sometimes our ML model might not correctly classify and can predict incorrectly as dog. That can also happen. In this example, it is doing correct classification. Coming to this types of classification, depending on how many categories have been defined for our data points and based on their features. Features are also called as characteristics or variables. The type of classification problem depends on how many classes exist. For instance, when you look at these three images, the first one says binary classification, and you can clearly see that there are two categories. One is, let us call them as a square category, another one a circle category, or the classes, square class or circle class. Here you have only two classes. The other examples of this type of uh, binary classification includes whether a student pass or fail, and whether will it rain or not, and does the patient um, report shows malignant or benign tumors, or whether the shares of a particular company go up or down. These are examples of binary classification. Moving on to multi-class classification, you can clearly see here there are three different categories, or three classes, or three labels, or three targets. In category 1 we have our squares, category 2 are our circles, category 3 are our rectangles, no, triangles. So we have squares, circles and triangles. So these are three different categories. Example of this can be the weather forecast will say will it be sunny, rainy or windy. These are three classes. One class is sunny, second class is rainy, third class is windy. Or you can say that a student will pass the exam, fail the exam, or results are withheld. Sometimes results are withheld. So there are three categories in this, or three classes. Or if I consider this a CT image of lung, the three categories can be whether the image shows pneumonia, or it shows uh, there is some disease, pulmonary obstructive syndrome, or it is healthy, means no disease. So again you have three classes. So these are the examples of multi-class classification. And then multi-label classification is in fact same. There is no difference as such with multi-label or multi-class, because both of them refer to the same thing. Class, label, target, category, they are all synonyms. Here not only three, when we talk about multi, it is more than two. It can be any number. I have given you examples of three based on these image, whereas we can have even four classes, or we can have five classes, okay, depending on the data set. And when we discuss about binary classification, this takes us to the understanding of a simple classification strategy which puts the data points into one of the two classes or categories. And this is the simplest of all. Model analyzes input features and decides which of the two classes the data belongs to. Here some important aspects of binary classification are two classes only. It will not have more than two classes. Again, common examples are here. Decisions are based on features which include, when we talk about students' performance, we saw last time that we used two features: hours studied and attendance percentage. So these are the two features based on which we can say whether a student will pass or fail. In multi-class, the data is divided into more than two categories. The characteristics of this type of classification includes there are multiple classes, and each data point will be assigned to one of the several possible categories. Why are we calling it as several? Because it can be 3, 4, 5 and so on. But the idea here is so on means it is not infinite. It is still discrete. We have fixed number of classes. We cannot have infinite number of classes. Either it can be 10 classes also fine, 2 also fine, 3 also fine, but you should have discrete number of classes. Eventually we get a single final prediction, only one class. And example include image in which the image can contain a cat, a dog or a bird. Multi-label, what it is saying is that it allows a single piece of data to belong to multiple categories at the same time. Unlike multi-class classification where each point is assigned only one class, this approach allows model to assign multiple labels at the same time. Okay, so there is a difference between, as per this article, there is a difference between multi-class classification, multi-label classification. and it states that in multi-class each data point belongs to exactly one class, whereas in multi-label classification it says that a data point can belong to one or more classes. Sometimes classes are not mutually exclusive. For instance, when you talk about movies, you can put the movie into more than one class. For instance, you can have a action comedy movie. So there are two classes, action and comedy both. Multi-label classification mean that a data point can belong to more than one class. This brings us to the working of the classification. How it works? It works in some steps. Already when we consider data science, when we learnt about data science, we have gone through all this. This is like revisiting of that. But then the difference is that in data science, it is a very broad area, whereas machine learning classification concept focus mainly on model training, evaluation, prediction and improvement. But then you cannot do these tasks without data collection. Therefore, our entire process begins with data collection, where we start with a data set, and in the data set each data point has a correct label, and when you move on to the next step, here it is all about feature extraction, which indicates that not all the features are important. In our last class we learned that when we understood the steps of the data science, we were finding the correlation between the features, and we have found that student ID is not correlated with the GPA. It means that student ID does not have any impact, and you can eliminate it without any change or without any influence on our outcome. Whereas hours studied and attendance both are having um, 90 greater than 90% of the correlation with the class. That process is called as feature extraction and feature engineering. In model training, we the algorithm learns patterns um, that connect features to a correct class, and model evaluation is to test the model on unseen data to measure its accuracy. Prediction is to provide a new data point, and actually they both are same. Model evaluation, in order to evaluate a model you do prediction. So as I told you earlier, some of the books, some of the articles, um, they, they may not follow the same number of steps. There is no standard number of steps that define our classification process or data science process. However, these two mean the same. While evaluation, you also make prediction, and you observe its accuracy. The model predicts the class of new data based on the learned pattern. Model improvement. If performance is not satisfactory, the model or its parameters are adjusted and retrained. Model improvement is also called as fine tuning of the model. And when you make a hyperparameter adjustments, it is called as a tweaking of the mm, hyperparameters. Well, I hope so far everything is clear to you all. Having said about the basics of classification, now we are moving on to the classification algorithms. The process of classification is clear, and let us now analyze algorithms. To implement a classification model, it is important to understand the algorithm, and we have several algorithms. The basic algorithm is logistic regression, the simplest one among all the algorithms. And broadly, classification algorithms can be grouped into um, two primary categories, and these categories are not fixed again. This is one of the categories with respect to whether you are creating a linear boundary or a non-linear boundary. um, the algorithms are divided into two types. First one are called as linear classifiers, second one are called as non-linear classifiers. Linear classifier models create a linear decision boundary between the classes. As we learnt about the line equation y is equals to mx plus c, which creates a straight line and divides the data points into two classes. That is a linear decision boundary. It is called as linear decision boundary. These are simple and computationally efficient models. They include logistic regression, support vector machines, single layer perceptron, stochastic gradient descent classifier. Please note them down. These are all so important things, student, and this will really give you an edge over other students if you remember all these points. Logistic regression, support vector machines, single layer perceptron, stochastic gradient descent classifier. And I'll share this link. When you click on each one of them, you will be directed to the page of that particular algorithm. You can do that, go there and study whatever are available in our syllabus. We will study all of them. Others which are not part of our syllabus, I encourage you all to study. It gives us more meaningful knowledge about ML. Non-linear classifiers where they create a non-linear decision boundary to separate the classes, and they capture more complex relationship between input features and target variable. Some common non-linear classification models include k nearest neighbors, kernel SVM. Kernel SVM is non-linear classifier. Naive Bayes. Decision tree classification. Random forests, AdaBoost, bagging classifier, voting classifier, extra trees classifier, multi-layer artificial neural network. These are all belonging to the category of non-linear classifiers. Applications of classification include spam email filtering, credit risk assessment. In this, when a applicant applies for a loan, his or her credit score is checked and based on that the model will predict whether the applicant will repay the entire loan or will go into the category of loan defaulter. Loan defaulters are those who don't pay the loan on time. Medical diagnosis, that includes whether a subject means a person who is being tested, so whether a subject has cancer or not, diabetes or not, BP or not. There's so many other things you can say. Image classification is used in applications uh, like facial recognition. When you have been given the picture having um, 4 or 5 faces, is our model predicting the correct face, means a person name from the face. Autonomous driving, you know about it. We have already seen that in USA. um, Waymo, I think Waymo, autonomous vehicles are currently running on the roads of US, which are even Tesla also. Tesla autonomous feature is also available. Okay, and medical imaging, sentiment analysis, whether the text. Yesterday we saw NLP. In that NLP, what we have learned that if I say I love programming, because of the word love, that particular sentence will be categorized as positive. If you say I hate programming, because hate is a negative word, sentiment will go into the negative category. Or if you say that I neither like nor hate programming, it is a neutral statement. Fraud detection, it identifies unusual transaction patterns. When suppose you are buying something on a e-commerce site and you provide your credit card, suppose your credit card number has been leaked, then um, a fraudster can also use your credit card number and can try to make a payment, whether the system identify it or not. So that is fraud detection. And recommendation systems, based on the products or the content you prefer, you you watch, you will get um, new recommendations based on that. Is the introduction to classification clear? Very good. So to make you understand, students, I'm going very slow. Just we completed one topic. But no issues. Anyway, you all are cooperating with me. You cooperate and we'll have classes every day. And we'll learn everything slowly and perfectly. Introduction to classification is done. Now we will look at linear classification. Just now we saw what a linear classification is. Still we'll go a little deeper into that by analyzing the differences. Linear versus non-linear classification. As we know, classification is a fundamental task in ML where goal is to assign a class label to a given input. And it has linear as well as non-linear approaches. SVM are a popular choice for classification due to their robustness and effectiveness. Okay, this is about SVM, but we cannot say that it is the only best classification algorithm. Every classification method or an algorithm or an approach is best or good for particular data set. Not all algorithms. Yes, Aditya, I am recording. I'll share. Not all algorithms are suitable for all kind of data sets. So some of you might be good at the subject DAA. Some of you may be good at DEP. Some of you may be all-rounders good at all the subjects. But there is a inclination, towards a particular course. You may feel that you like Java programming more than Python, some of you. The others might say no, Python is better than Java. So there is like, we cannot say that every approach is best for every data set. It all depends on what kind of data set you are using and which algorithm is best suited for that particular data set. And just now we saw no SVM. Here SVM is available in both linear classifier category as well as non-linear classifier. In non-linear classifier we call it as a kernel SVM. Here linear is just an SVM. Students, I hope you understand. I am hiding something from this, and I want to ask you, depending on this linear and non-linear classifiers, which one is linear classifier and which one is non-linear? Image 1 or image 2? You put as per your understanding. You just answer to me. Today the strength is very low. Left one is linear. Okay. Image 1 is linear. Very good. And others? Only 2 students have understood. Okay. Now you tell me. You both are saying that image 1 is linear. Why? Why are you calling it as a linear image? Linear classifier. Yeah, because there is a straight line. There is a straight line. Linear, it has a linear. Very good, Aditya. Correct. You have correctly put that it has a linear decision boundary between the classes. So here we can see that uh, this is red class, this is blue class. Red class and blue class, both the classes are separated using this straight line. That's why it is called as linear. And here you can see that there is no straight line. There is uh, some kind of a shape it is. That is distinguishing or classifying blue classes and red classes. Some other shape, not a straight line. It is looking like a bean. Okay, so I just wanted to explain from this what is this linear and what is non-linear classifier. And again here you see that image 1 is having a linear straight line. This is linear and this is not a straight line. It is non-linear. Okay, linear classification I hope is clear to you all. Our next topic is logistic regression. Do you all remember regression? Do you all remember the difference between classification and regression? If not, let us quickly, very quickly, um, revise it. So regression predicts continuous numeric value. Continuous numeric value. Classification predicts a categorical label. This is the primary difference between these two. So apparently we will get from regression a numeric output, whereas in classification we get a category or a class or a label or a target output. There are some other differences as well which we already learned. I just wanted you to recall that the output of regression is continuous numeric value and the output of classification is categorical label. Now you might think that logistic regression is a regression mechanism which means gives us a continuous numerical value. However, that is not the case. Though the name contains regression, it is a classification approach. It is not a regression approach, which means that logistic regression is a classifier. Logistic regression is a supervised machine learning algorithm used for classification problems. Unlike linear regression, which predicts continuous values, it predicts probability that an input belongs to a specific class. This is very, very important point. Please note down, students. Linear regression is a regression technique which predicts continuous value. In contrast to linear regression, logistic regression predicts a probability and that probability indicate to which class the data point belongs to. It is used for binary classification where the output can be one of two possible categories. It can be yes, no, true, false, 0, 1. As we know that binary classification has only two classes. So logistic regression can be used for binary classification with two classes. Also, in logistic regression, we have a sigmoid function. Because of this sigmoid function, it converts the output into a probability value between 0 and 1. Sigmoid function is responsible for giving us probability value. From the probability value, we determine the class. Let us look here what is given. What is logistic regression? It predicts binary outcome. It uses sigmoid function. It is ideal for classification, and its working is that it takes input features, and it is a linear classifier. Logistic regression is a linear classifier, so it through linear combination it gets the output, and on that output it applies sigmoid function, this S function. This S function is a sigmoid function. And then this sigmoid function, if you put a line around it, not around it, in the center of it, all the probability values above 0.5 belong to class 1, below 0.5, above or equal to or above 0.5 is class 1, below 0.5 is class 0. Like that, logistic regression determine the class. This is linear regression, a straight line. Here we are predicting continuous values. We uses best fit line. We solve regression problems. In logistic regression, we predict categorical value. We uses sigmoid S curve. This curve is called as sigmoid S curve. This curve is obtained after applying sigmoid formula on the output that we receive from linear regression formula. What is our linear regression formula? Well, it is y is equals to mx plus c. And what is sigmoid formula? 1 by 1 plus e to the power of minus y cap. So y cap is equals to mx plus c, let us say, and 1 by 1 plus e to the power of minus y cap if you put, then you are transforming the linear output into a probability value. And types of logistic regression, it can be used for binomial where we have only two classes, multinomial where we have multiple classes, two or more, ordinal where we have classes based on the some predefined categories. Let us look at this ordinal versus nominal data. Data types are so many, there are different types of data. You have this here we have 4 level of measurements. What are the level of measurements? Nominal, ordinal, interval, ratio. In this categorizes and label variable, means we have categories and the labels for the variables is present in all the 4 types. And rank orders, rank ordinal means ranking, order means ordinal, ranks will be there in that. Like for example, if you say manager, assistant manager, supervisor, employee, so here we have some kind of ranks. In military also we have some ranks, so that is present in this ordinal type of data. So here you see there are 4 types. These 4 types are like data. They can be nominal data, ordinal data, interval data, ratio data. So the data which has categories and labels, it can come into any type. but which specifically has ranks or order, it is ordinal. And which has known equal intervals, known intervals. Then if we say 10, 1 to 10, 11 to 20, like intervals if we have, then it supports these two properties. And which has a true or meaningful zero, then it is just a ratio. So there are four types of data: categorical, which is further divided into nominal and ordinal, and numerical, which are further divided into interval and ratio. So we have these different types of data. Nominal data uh, is a basic data type that categorizes data based on some labels. There is no hierarchy. In nominal data, there is no hierarchy. In ordinal data, we have a hierarchy like middle class, like wealthy, middle, poor. Internal data, it can be like temperature scales like Celsius, Fahrenheit. Ratio data is the measurement of ratio data. Similar to interval data, it categorizes and arranges data utilizing measured intervals. But unlike interval data, ratio data includes a genuine zero. In interval data, there is no zero. Whereas in ratio data, we can have even a zero. This is very important, students. You know something, in order to become a data scientist, you must be so expert in the data, in the categories of data, in the types of data. So nominal data example include color of a car. There is no hierarchy, there is no comparison. You can say that is red color greater than white color? No. Or is white color greater than red? No. Types of food, movies. This is example of categorical. Ordinal data, where we have like school grades, first standard, second standard, third standard. Here we have like ordinary, some kind of levels. Educational level, the one who study bachelor's, master's, PhD. Again we have levels: seniority level, junior, senior, mid level. This is the example of the comparison of nominal data and ordinal data. And in nominal data we have distinct and discrete. Here also same, but here there is no ordering. Here we have inherent ordering or ranking. No meaningful numerical value. With respect to numerical value, there is nothing, but with respect to some categories, we have here ordering, here no ordering. So here you can see in ordinal data you have this red color, yellow color, green color, some kind of levels, orders. Rank means green is having higher rank than yellow, which is having higher rank than red. Okay, then assumptions of logistic regression. Each data point is assumed to be independent, and it takes assumption that the dependent variable must be binary. For more than two categories, we have to use softmax function. Note down this point also, very important point. We are saying that basically logistic regression is used for binomial classification, but it can also be used for multinomial. In that case, we have to use softmax function. There is a linearity relationship between independent variables and log odds. Some kind of linear relationship exists, and there are no outliers. The data set should not contain outliers. Note down outliers are also very important. Hmm. So here you see, these are our data points. And there are three data points which are very far from these green data points. Very far. There, there is no similarity between these points and these points. So now you can put these three red color points into the category of outlier. Outliers are data points that are essentially statistical anomaly. Anomaly means what? Some kind of error. It is like not same as others. A data point that significantly deviates from other observations in a data set is called as an outlier. These are significantly different from this. When you look at their x and y values, when you compare x and y values of all these green data points, these are much higher. That's why it is called as outlier. To work with logistic regression, you should not have outliers. And also logistic regression requires a large sample size. In order to understand sigmoid function formula, let us say this is the matrix that represents our values, and there is a dependent variable y. Y is 0 if x is 1. No, if class is 1, y is 0. If class is 2, y is 1. And there are two classes, 0 class, 1 class. So that is output. Y is the output or dependent variable, and x is the input or independent variable. And then we apply a linear function. Here this is a linear function. And this is multilinear function because when you have multiple features, you have to use this I1 to n wi means w weight, and x is a input variable. When you have multiple input variables, you have to use this summation of O. And then there is a bias. And so here we get z is what? A linear value only. It gets a linear value because we are using a linear equation. This is a linear equation. And now we apply sigmoid function. This is our sigmoid function. What does it do? It changes the z value. What is the z? Z, instead of calling it earlier in our linear regression, we called this as y. Now we are calling it as z. So z equal to w into x plus b, and 1 by 1 plus e to the power of minus z. Due to this, the output will range from 0 to 1. And because of that, we get a S-shaped curve. And if you put the threshold value to be 5 here, look at my cursor pointer. If you're putting it here, then whatever is equal or above 0.5, all these data points go to, let us say, class 2. Here class 2. and all the other data points which are below this goes to class 1, means 0. Sigma of z tends towards 1 as e. So we actually have a continuous output only. Z is what? A continuous output. But after the application of a sigmoid function on z, we get a value between 0 and 1. Okay, this is using natural logarithm. We are obtaining this this logistic regression equation, which is sigmoid function. It is very obvious, very clear. You go through. If you don't understand, then we will look at it. Okay, the terminologies involved in logistic regression includes independent variable, which are also called as features of predictor variables, dependent variable, target variable, logistic function, which is a sigmoid function. Odds means the ratio of the probability of an event. Log out odds, this is also called as logit. It is a natural logarithm of the odds. Quotient means the parameters like W. Intercept is the constant term which is a bias B. Maximum likelihood estimation, this is a method used to estimate the coefficients of the logistic regression model by maximizing the likelihood of observing the given data. By applying this MLE, we estimate the this is what coefficients. Coefficients are also called as weights or the parameters. This is the implementation. So here let us look at the difference between linear and logistic regression. Linear is used to predict a continuous dependent variable. Logistic predict a categorical dependent. Problem type, solve regression problem, solve classification problem. Output is continuous variable, categorical variable. This is, here we find the best fit line. Here we find the S-curve. Here estimation method is least square estimation method. Here we use maximum likelihood estimation. Output example is price, age. Here output example is 0, 1, yes, no. Relationship requirement, it required linear relationship between dependent and independent variable. Here that relationship is not required as we are putting a S-curve on top of it. Collinearity, there may be collinearity between the independent variables. There should be little or no collinearity between independent variables. Independent variables should not be related. Here even if they are related to some extent, linear regression works.